I'm going to be going through L91B. This question is very similar to the example given on L91A, so I would suggest you look at that after watching this video if some parts don't make sense. The example provides all of the explanation. So if we look at the question, it says find the maximum value of f of x on this said interval. So x is in between 0 and a inclusive, and a is greater than 0. First of all, ignore the interval. How would you find the maximum value of f of x? You would do that by finding the local maximum point, which you would do through differentiating f of x. So differentiating f of x gives us 3x squared minus 18x plus 15. If we factorize that, we get 3x minus 5x minus 1. If we want to find the stationary points, we're going to set that to 0. So find out where the gradient is 0. We get x equals 1 and x equals 5 from here. Okay, next thing I'm going to do is I'm going to draw out the table, which will help me figure out the maximum and minimum points more easily. Okay, so we have the value of x, the gradient, which is f dash x, and the value of f of x. So we have 1, 5. We're going to find it out what happens before 1, what happens between 1 and 5, and what happens after 5. Okay, so we know that the gradient at x equals 1 and x equals 5 is 0. Next thing I'm going to do is I'm going to sketch out a generalized graph of f of x, which is just a cubic graph with 2 points, 2 stationary points, sorry. So it's going to look something like this. So we have the maximum and the minimum point. The maximum point is at x equals 1 and the minimum point is at x equals 5. Now we're going to look at the trend. So before 1, we have an increase in the gradient, and then after 1, decreasing gradient. So 1 is maximum point, and then after 5, we've got an increase in the gradient. So at 5, we have minimum point. So positive, negative, positive, up, down, up. And then we want to find the values of f of x at x equals 1 and at x equals 5. So you just substitute 1 into f of x and 5 into f of x, and you get f of x equals 7 and f of x equals minus 25 over here. Next thing you want to do is you want to find out the point where, because we're looking for the maximum over here, where f of x equals 7. So where is the second point where f of x equals 7? We have x equals 1, so it is at x equals 1. But where is the second point? We know it's going to be after x equals 5. It's not that relevant that it's after x equals 5, but if you get a value of x that is less than x equals 5, then you know that you've done something wrong. It's really easy to find out the second point. What you do is you substitute f of x equals 7 into this beautiful equation. So we're going to get x cubed minus 9x squared plus 15x equals 7. And then when you differentiate it, you're going to get x minus 1 squared, x minus 7 equals 0. You're going to get x equals 1 and x equals 7. We already know that it would be x equals, f of x equals 7 at x equals 1, but now we know that f of x also equals 7 at x equals 7 over here. This will be irrelevant when we're looking at this interval. So that is this part over here. Now, when looking at the interval, we don't know the value of a. All we know is that it is greater than 0. And so what we're going to do is find out cut the graph essentially into different sections and then find out what the maximum value would be in that scenario, in that case. So first of all, I'm going to go for when a is in between 0 and 1, uninclusive. If I draw a little sketch of the graph, oops, there we go, something like that, it would be this area of the graph. So this is x equals 1, and this is x equals 5, this is x equals 0. So this is the area that we're looking at. What would the maximum value be of this graph, essentially? And if we look, the greater the value of x, the greater the value of f of x. And so in this case, the maximum value would be f of a, because x is in between 0 and a is in between this interval. So we're going to just substitute a into f of x. That gives us a cubed minus 9a squared plus 15a. Now, the second case that you can get is, if I sketch the graph again, if we have a in between the interval and including 1 and 7. So 1 and 7, f of x equals 7. And that is because at x equals 7, we discovered that f of x equals 7. So we get the same local maximum value over here. And that's why it's its own section. So when it's in between these values, the maximum point obviously is just over here. So it's at f of 1. And we know if we substitute 1 into the equation above, we get f of x, f of 1 equals 7. You can also substitute x equals 7. You get the same answer. I would rather go for 1 just because that is the local maximum point, but both are technically correct. Next, what you can get is the last part of the graph, which is this bit where, oops, let's redo the highlighting. So this is x equals 1, this is x equals 7, this is f of x equals 7. So this section over here, and if we look at it, that is where a is greater than 7. And the maximum point over here would be f of a, and that is because as you go up the graph, as x increases, f of x increases as well. So the highest value would be whatever a is. So the end of the interval. So same as this over here, it's going to be a cubed minus 9a squared plus 15a. That is essentially the question done. The only thing I would do is then I'm going to summarize it. So from parts I, and I, we have when a is in between 0 and 1. So just this section over here. And it is greater than 7, so this over here. The maximum value is a cubed minus 9a squared plus 15a at x equals a. And then when a is in between and including 1 and 7, just over here, the maximum value is, as we can see here, it's 7 at x equals 1. You could also say at x equals 1 and at x equals 7, but I would just stick with x equals 1. So that is the question done. I hope that helped. So there is no concrete or fixed value of a. You just have different intervals of a that you can get, and obviously we can see that the maximum value over here changes depending on the range of a. This is the final like actual drawing of the graph that I did over here. If you need more help, or you want to, or if you don't understand any bits, go back to L91A and read the example really carefully, but I hope this video helped a little bit. Thank you.